Good day and welcome to your WTW 258 video series of Theme 1, Real Functions of Several Variables. So in this theme, we will cover the following: 1.1, Functions of Several Variables, 1.2, Partial Derivatives, 1.3, Tangent planes and linear approximation, 1.4, the chain rule, 1.5, Directional derivatives and the gradient, and 1.6, maximum and minimum values. It will also include semester test 1 questions which have been adapted and the 2020 study guide problems which are also adapted. So let's start with theme 1.1, functions of several variables. So you'll see in your calculus textbook, it is section 12.6, page 834 to 839, and section 14.1, page 888 to 898. So let's start off talking about what is a function with several variables. Now, in the previous knowledge that you've acquired, you've probably worked with y is equal to x squared, y is equal to x plus x squared, and so forth. So that included one dependent variable and one independent variable. But with functions with several variables, you have a dependent variable and you have several other independent variables. So the ratio of these two are not equal to 1 to 1. Now, the domain of a function is where x and y are defined or where they exist. You'll see that with square roots and ln and your denominators, that sometimes you can't just have x and y be any type of variable or any combination of variables. And then your range is where your f of x, y, or your z exists. For example, let's take a function like f of x, y is equal to 8 minus x squared minus y squared. If they ask you to find the domain and range, this is what you would kind of look to. So for the domain, we want to look where x and y exist or where they are not defined. Now, if you look at the function, you'll see that it is a polynomial. And for polynomials, you don't have any boundaries. You know that x and y can exist wherever they want to, and therefore this is the notation you will use. So the domain is x and y wherever in the real realm. So for the range, things might become a bit more complicated, and you'll have to examine the function that you've been given. So if we look closer, we see that 8 is always being minused by a positive value. It doesn't matter whether x is positive or negative, this will always be positive, and the same for y, this will always be positive. Therefore, 8 will always be less. So the function will always be less than 8. Therefore, the range of the function is negative infinity to 8, because it will only be equal to 8 when x and y is 0. So this will be your notation. So you'll start off saying z is in the range of z is equal to 8 minus x squared minus y squared, wherever x and y is in their domain, because it always needs to obey the domain. But since 8 minus x squared minus y squared is always less or equal to 8, we can say that z is always greater than negative infinity or smaller or equal to 8. And this is what you'll get for your range then. Another example would be f of x, y is equal to 8 minus square root x squared plus y squared. Now this is where things become interesting. So for the domain, we once again have to look where x squared and y squared would not be defined. Now since x squared plus y squared is within a square root, we know that whatever's in the square root needs to be greater or equal to 0. Therefore, x squared plus y squared have to be greater or equal to 0. And the domain would be written in this notation. Now for the range, we once again have to analyze the function that we've been given. So as per the previous equation, we know that the biggest value that this function could be is 8 when x and y is 0. And for any other variables of x and y, it would be less than 8. Therefore, we know that z is greater than negative infinity and smaller or equal to 8. So when finding your domain, there are a few things that you have to watch out for. A square root, because anything within the square root cannot be less than 0, so that cannot be negative. And then your ln, anything inside a ln cannot be negative or equal to 0. And then for denominators, you know that they cannot be equal to 0. The next part of this theme is sketching of curves and two-dimensional figures. So for two-dimensional figures, we know that we have one dependent variable and one independent variable. So let's start off with circles. You should be pretty familiar with these. So the general formula for a circle is x squared plus y squared is equal to r squared. Or if you shift it on the x or y axis, you'll find the following general formula. For ellipses, they are almost like circles but have the following general formula. So you can find a 2x squared plus y squared is equal to 9, or x squared plus 16y squared is equal to 9, or so forth. You will see that they will have values in front of x squared and y squared, where for circles, they are usually just 1 in front of them. And then you'll have parabolas, which you should be very familiar with. Y is equal to ax squared plus c, and hyperbolas. Haven't personally seen them very much in this course, but it is always good to know. So this is the general formula for a hyperbola. And then for a straight line, you should really know a straight line by now. It's y equals to mx plus c. Now, the new things that you'll be learning is three-dimensional surfaces. Now, the first three-dimensional surface is a sphere. So the general formula for a sphere is x squared plus y squared plus z squared is equal to a squared. An example of this would be x squared plus y squared plus z squared is equal to 9. So for a sphere and an ellipsoid, when you want to sketch it, you have to get an idea of what it could possibly look like. So what I would suggest you do, if you want to find the intersection of z, y, and x on their respective axes, if you want to find the x intersections, you say y and z is equal to 0. And if you want to find the y intersections, you say x and z is equal to 0. And you do the same for z. So for us to get the z intersect, we would say x and y is equal to 0. Therefore, z squared is equal to 9, and z is equal to plus minus 3. To get your x intersect, you will just say z and y is equal to 0, and therefore x squared is equal to 9, and x is equal to plus minus 3. And then you would do the same for your y intersect, so y would be plus minus 3. And then you'll find that the sphere would look as follows. The next three-dimensional surface that you will be taught about is an ellipsoid. So similar to circles and ellipses, an ellipsoid looks similar to a sphere. So you'd have x squared over a squared plus y squared over b squared plus z squared over c squared is equal to 1. Very important to remember is that this is a 1. So an example of this would be 2x squared plus y squared over 9 plus z squared over 4 is equal to 1. Now, similar to a sphere, if you want to sketch this, you can find your x-intersect by saying y and z is equal to 0, and you can find your y-intersect by saying x and z is equal to 0, and the same for your z-intersect. So in this case, our z-intersect was plus minus 2, and our x-intersect was plus minus 1 over square root 2, and our y-intersect was plus minus 3. So then when you sketch it, you'll find that your z intersects at 2, your y intersects at 3, your x intersects at 1 over square root 2, but also on the negative sides as well. And then you'll have an idea of what this surface might look like. The next is a plane, and this is the formula for a plane. AX plus BY plus CZ is equal to D. So an example of this plane would be 2x plus y minus z is equal to 4. So you do the same as for your sphere and your ellipsoid. To get your x-intercept, you say y and z is equal to 0. And then you'll find that x-intercept's at 2. And then to find your z-intercept, you say x and y is equal to 0. And you'll find that z-intercept's at negative 4. And then for your y-intercept, you say x and z is equal to 0. And then you'll find that y is equal to 4. And then when you sketch it, you'll find these intercepts. Technically, you'll have a whole sheet for the plane, but this is the best way of indicating to you how it would look. The next one is cylinders. And there are two types of cylinders that you will encounter, a parabolic cylinder and a normal circle type cylinder. So these are examples of the two different cylinders. So this one would be a parabolic cylinder. You'll see it looks like the normal formula for a parabola. And this would be your circle type cylinder, and it looks like the general form for a circle. But when we are talking three-dimensional, we talk about sheets. Therefore, if you want to convert this to a three-dimensional figure, then you'll see that the z is equal to y squared will go on the x-axis like a sheet. And the z squared plus y squared is equal to one circle, which revolve around the x-axis as well. The fifth surface that you'll encounter is a paraboloid, and the general formula for the paraboloid is z is equal to by squared plus ax squared. And an example of this would be z is equal to 2y squared plus x squared over 4. So for paraboloids and cones, you'll see that you can't say x and y is equal to 0 when you want to see the intercept of z. So to get an idea of what the surface looks like, you can't just equate all of them to 0, because for instance, if you say y and x is equal to 0, you'll find that z is equal to 0, and the same for y and x. So basically what you'll have to do is, instead of saying two things are equal to 0, you just say x is equal to 0, and then you'll find that z is equal to 2y squared. And then you can sketch that for yourself on the zy plane, and you'll see the shape of the zy plane and what it would look like. And then you can do the same for the xy plane or the xz plane. So all of your intercepts will be at 0 unless it's shifted up or down. So to get your shape of your paraboloid, let's say you say x is equal to 0, so you'll find z is equal to 2y squared. So on the zy plane, this is what it would look like. And then if you say y is equal to 0, you'll find that z is equal to x squared over 4. And then on the zx plane, this is what it would look like. So then you have an idea of the two sides of the paraboloid, and you can sketch your paraboloid as follows. So that just gives you an idea of what the paraboloid would look like. The last surface that you'll encounter is cones, and they have the following general formula. So z squared over c squared is equal to x squared over a squared plus y squared over b squared. Or sometimes you'll find that the lecturers are sneaky and they'll give it to you in the following form. So they'll say z is equal to plus or minus square root of something x squared plus something else y squared. Sometimes they will just give you a positive, so they won't give you anything, and that will just be assumed as the positive z side of the cone. And sometimes they will give you a negative, so all of your z values have to be negative. So an example of this would be the following. So let's say they give you z is equal to square root 4x squared plus y squared. So then you have to note that this is the positive half of the cone, and therefore you will only have the positive side of z that you sketch. So you can do as we've previously discussed. So you say let x equal to 0, and then you'll find that z is equal to plus minus y. So that is a straight line, right? Well, two straight lines, since it's plus minus y. And then you say let y is equal to 0, and you'll find that z is plus minus 2x. So when you sketch it, you'll find that it would look something like this. Now, normally, your cone will have both a top part and a bottom part that corresponds with the top part. But since they only asked you for positive z values, you only sketch the top part of the cone. Okay. So let's start to talk about level curves. So a level curve of a surface is basically if they ask you to sketch a projection of a curve onto the XY plane or one of the three planes that you have to sketch it on. So let's say, for instance, you have a function of fxy is equal to x squared plus 16y squared. So the first thing you have to know is this is an elliptical paraboloid. The second thing, you say let fxy is equal to k, where k is a constant. So let's cut this paraboloid where z is equal to a constant. So let's say z is equal to 1 or z is equal to 2. You want to see what that function's boundary looks like at that point. So then, number 3, you choose values for k if a specific value was not assigned. Sometimes they will not assign a value and they'll say just sketch a few level curves, and sometimes they will give you sketch a level curve where k is equal to 2 or 1. So k can be 0 as well, but in this case, since it's a paraboloid and it has not been shifted up or down, you will have a dot because that will be at the origin where z, x, and y is equal to 0. So the level curve where k is equal to 1, you'll have x squared plus 16y squared is equal to 1. So that is an ellipse, right? So when you sketch that on your xy plane, this is what you'll find it to look like. So that's basically just the projection of this paraboloid at a specific z value onto your xy plane here. And if we have to sketch it where k is equal to 2, that will be where z is equal to 2. And you'll find that it will be x squared plus 16y squared is equal to 2. And it would look as follows on the xy plane. Note that this can be done for any type of multivariable function. Let's say you have fxy is equal to x e to the power of y. And they ask you to sketch the level curve where k is equal to 1. So then you say x e to the power of y is equal to 1, and then to get the shape, since you don't know exactly what the shape is, you say if x is equal to 1 here, what would y be? So if x is equal to 1, we can calculate it and we know that y is equal to 0. So you can sketch a dot here for you. And then what would y be if x is equal to 2? So then you just fill that in, x is equal to 2, you take it over, and then you'll find that y is equal to ln of a half. Or if you could use a calculator, which in this case, unfortunately, you can't, you would find that it's negative 0.693, so that's the next dot, and so forth. You get the idea. So the next part is intersections of three-dimensional curves and their projections. So sometimes they'll ask you to sketch the intersection of two three-dimensional curves. So let's say, for instance, they will ask you to sketch the intersection of a sphere and a paraboloid. As, for example, they ask you to sketch the intersection of z is equal to x squared plus y squared, which is a paraboloid, with x squared plus y squared plus z squared is equal to 4, which is a sphere. So if you want to, you can start off by actually sketching both of them, and you'll find that it looks something as follows. Obviously, the sphere has a bottom part as well. And then you have to manipulate the equations to get an equation for the intersection, noting that the intersection will be a two-dimensional shape. So when you substitute equation 1 into equation 2, you'll find the following. Z plus z squared is equal to 4. And then if you manipulate it further, you'll find that z squared plus z minus 4 is equal to 0. And then you can use the following formula to get your different z values, noting that this has to intersect at the positive z. So since you don't have a calculator, I arbitrarily chose these functions, therefore they will not naturally work out. So when I used my calculator, I found the following values for z, and since we only are going to use the positive z, we are using z is equal to 1.56. And then you substitute the value of z into either of the two equations. So x squared plus y squared is equal to 1.56. And obviously, you will not get such strange answers since a calculator is not used. But then you can sketch what it looks like on the xy plane. So it would look something as follows. So off to the study guide problems. So in the first study guide problem, they are asking us to find the domain and range and sketch the following functions. So the first function that we have to define the domain and range of and sketch is fxy is equal to square root 9 minus x squared minus y squared. Now, if you look closely, you'll see that this is a sphere, because if you take the square root over, it will be z squared is equal to 9 minus x squared minus y squared, so it will be z squared plus x squared plus y squared is equal to 9. So it should be pretty easy to sketch. If you want to find the z intersection, you say x is equal to y is equal to 0. And if you want to find the x-intercept, you say z is equal to y is equal to 0, and the same for the y-intercept. But note very importantly that this is the positive half of the sphere. And this is why they like to write it like this. Now, to find the domain and the range. For the domain, we want to know where does x and y, where are they not defined? And since we have a square root, that should be easy by now to see, because everything under the square root has to be positive. So 9 minus x squared minus y squared has to be greater or equal to 0. So then our domain would be xy, where 9 minus x squared minus y squared is greater or equal to 0. Right. Okay. So for the range, we have to analyze our function. So we see that we have a 9 here, and that 9 will always be minused by a positive value. Right. So if x and y is equal to 0, then we know that we have square root of 9. But if x and y is anything else than 0, we know that we have everything less than 9. But this cannot be less than 0. It can only be equal to 0. So the smallest value that this can be is 0. It cannot be negative infinity. It has to be 0. So the range would be 0 to 3, since 3 is equal to square root of 9. And then the next question we have to define is f of xy is equal to 9 minus x squared. Noting that this is a form of a parabolic cylinder, since we only have x squared, and it's a negative parabolic cylinder that's been shifted up 9. So sketching that shouldn't be too difficult. So the domain of this, since it's just a polynomial, there's no square root, no ln, no denominator, x and y exists wherever. So x and y is an element of all real numbers. Cool. So for the range, we know that 9 will always be minused by a positive number. Therefore, 9 would be the biggest number that we'd have, and any value for x will result in this function being less than 9. So our domain would be equal to xy, where it is in the range of all numbers, and our range would be from -infinity to 9. Okay, the next function, so we see we have a square root here. Okay, so that's the first thing that should catch your eye. The next thing to note is that this is a negative part of a cone. Since there's a negative in front of here, square root x squared plus y squared. So you'd see for a sphere, you'd have negatives in front of here if it was in this shape. So you can sketch that cone by checking x is equal to 0, and then you'll see the shape of z and y, and you can do the same saying y is equal to 0 and then seeing the shape of z of x. So the domain we can check, so we need to know that x squared plus y squared has to be greater or equal to 0. And then we can write our domain as follows. And the range would be similar to the previous question, where we know that this is always going to be a positive value. So the biggest value for f of xy that we can have is 9, because 9 will always be minused by a positive value for all values of x and y. So our range would be -infinity to 9. Okay. So the next question they'll ask is, sketch a few level curves of the following functions. Now the first function that they gave us is f of xy is equal to x squared plus 16y squared. And we know that this is an elliptical paraboloid. So let's say that k is equal to 1. So then we know that the function is x squared plus 16y squared is equal to 1. And then you can go sketch that on the xy axis. So we can see from this function that x will be 1 and -1, and then if you manipulate y, you'd see it intersects at a quarter and -1/4, and then you can just sketch it. Obviously, it's always better to have a ruler at hand to do this a bit more professionally. But yeah, that is what you would do to sketch the level curve. And the last question is, describe the level surfaces of. So here we have a function of 3 variables. Now, if they're asking for a level surface, it's almost like a level curve, except now you have 3 variables. So we'd still say that f, x, y, z is equal to some constant. So let's say the constant is equal to 1. So k is equal to 1. Then you'd have 2x plus y plus 4z is equal to 1. And we know that that is a plane. So how you would approach a plane is you would get your intercepts. So getting your x-intercept, you'd say y and z is equal to 0. And then you'll find that 2x is equal to 1. So x-intercept would be 1/2. And then to get your intercept for your y, you say x and z is equal to 0. So then you'll find that y is equal to 1. And to get your z-intercept, you'll say that x and y is equal to 0. Therefore, you get 4z is equal to 1. and z is equal to quarter. And then you can go sketch that on your three-dimensional axes. So you would have the following, and then z would be a quarter, x would be a half, and y would be 1. So your plane looks almost like this. And that would be how you sketch that. And then this also occurs in some semester tests, where they ask you to find and sketch the domain of a function. So this is a bit of a more complicated function, but we know that to get the domain of a function, we need to see where x and y would not exist. So we look for square roots, we look for a ln, we look for denominators. So in this question, we have a square root and we have ln. So we know that x squared plus y squared minus 1 has to be greater or equal to 0. And we know that 4 minus x squared minus y squared has to be greater than 0. It cannot be equal to 0 or less than 0. So then when you rearrange these two, you'll find the following. You'll find that x squared plus y squared has to be greater or equal to 1, and that x squared plus y squared has to be less than 4. So when we go sketch this on the xy plane, we can see that this is a circle, so the value has to be greater or equal to 1. So this is the circle of x squared plus y squared is equal to 1. So whatever the value is, it has to be outside of this circle. And here we know that the value has to be inside of this circle, because we have x squared plus y squared is equal to 4, which is the following. But it cannot be equal, it's less than 4. So it cannot be on this boundary, it has to be less than this boundary. So it has to be beyond this one or equal to it, and it has to be smaller than this boundary. So it is in between these two circles that you will find your domain.